Hello everyone, we are the team behind PySync. This is a directory synchronization utility written in pure C, designed to work as a lightweight alternative to rsync. Our main goal was not just to copy files but to do it efficiently and safely, using system-level programming concepts. We broke the problem down into three independent stages: crawling, gathering file metadata, diffing, comparing the source and destination, and execution, multi-threaded copying or deleting. I'll hand it over to Andre to explain how we store and process this data.
Let's start with the foundation, our data structures. Because file systems vary wildly in size, we couldn't rely on fixed arrays. We implemented a double linked list. In list add, you will see that we maintain both head and tail pointers. This allows us to append new files in OOP1 constant time, which is critical when scanning directories containing hundreds of thousands of files. Next is a crawler, which populates these lists. The entry point is list_dir, which initializes the structure, and then the heavy lifting happens in list_dir rec or recursive. This function uses open_dir and read_dir to iterate through entries. We explicitly filter out dot files to prevent infinite loops. When we encounter a directory, the function calls itself recursively, building a flat list of every file in the tree, completely abstracting the hierarchy for the sync engine. Finally, the sync module. In compare lists, we generate a task list representing the difference between source and destination. It works in two passes. First, we iterate the source list. We calculate the relative path of each file and look for it in destination. If it's missing, we schedule a copy. If it exists but has a different size or modification time, we schedule an update. In the second pass, if delete mode is enabled, we check the destination list for files that no longer exist in the source and mark them for deletion. This ensures the destination becomes an exact mirror of the source.
Hello, I'm Andriy and I will explain how we handled concurrency and memory safety in this project. To make file synchronization efficient, we implemented a custom thread pool. Instead of creating a new thread for every single file, which would be very expensive for the operating system, we used a fixed number of worker threads that stay alive through the program's execution. In our header file, you can see how we define the thread pool structure. It manages a queue of work items using a linked list. The core logic resides in this worker function. It follows the classic producer-consumer pattern. The main thread acts as the producer, adding tasks to the queue, while these worker threads run in an infinite loop, picking up tasks and performing heavy I/O operations like file copying or hashing. Of course, when multiple threads access the same queue, we must prevent race conditions. To ensure thread safety, we used POSIX synchronization primitives. We use mutexes to lock the queue whenever a thread needs to add or remove a task. This ensures that only one thread can modify the queue at any given time. To make the system CPU efficient, we used condition variables. Instead of busy waiting and wasting energy, our threads go to sleep when there is no work. They only wake up when they receive a signal from the producer that the new task is available. This allows our tool to handle thousands of files with almost zero idle CPU usage. Another major focus was strict memory safety. In C, every dynamic allocation must be manually tracked, and with multi-threading, this becomes even more complex. We implemented a robust cleanup process in our thread pool destroy function. When the program finishes, we broadcast a signal to all threads wait for them to terminate using pthread join, and then meticulously free all remaining tasks in the queue, the thread array, and the synchronization primitives themselves.
Let's look at a quick demo. Here we have a source folder and an empty destination. We run pysync with the verbose flag -v. As you can see, the program created the necessary subdirectories and copied the files. If we run it a second time, it does nothing because the files are identical. And if we delete file in the source, pysync will remove it from the destination as well.